Thank you, Joanna. So as she said, my name is Liz White. I'm a research associate at VTTI with the Center for Technology Implementation, and I've been helping to manage our VCC deployment for the last year or so. And I just wanted to mention a few of their team members that will likely be joining me for the Q&A session. John Paul Toledo Valela is an embedded hardware team leader here in our Center for Technology Development. And Mike Mollenauer actually created this slide deck, but he won't be able to join us today, but he's the director of our Center for Technology Implementation. And Zach Dorzoff may be joining us as well at the end, he's the director of our Center for Advanced Automotive Research here at VTTI. So this first slide just shows where our Virginia Connected Corridor testbed is located. So our primary deployment is in the Northern Virginia area, and we also have a smaller deployment in Southwest Virginia on the Smart Road here at VTTI, which is a closed testbed research facility that we manage and is owned and maintained by the Virginia Department of Transportation. And VTTI has partnered with VDOT on this deployment, and our mission, as you can see here, is to provide an open, connected vehicle environment where technologies and concepts can be developed, tested, deployed, and evaluated in a real-world operating environment. This next slide shows a little bit more detail of the Northern Virginia testbed, which is our primary deployment. And this testbed is located along several of the most congested corridors here in the United States, which is why we chose to deploy on these particular roads. The lighter colored pins here show where we have GSRC RSUs with SPaT and MAP capabilities on them. We currently have 30 of those equipped intersections in total, and we also have 19 RSUs located along major freeways, which are I-66 and I-495, that do not currently have the SPaT or MAP capabilities. And we specifically chose to deploy SPaT and MAP on this set of contiguous intersections so that people driving through the area could receive information from each intersection, and also so we can send data from those intersections to associated applications. This next slide here is a representation of our VCC cloud system, which is a data hub and archive, and also does application processing. As you can see in the upper right-hand corner, we do make all of our data from the VCC publicly available through a website called smarterroads.org, and data is pushed there on a regular basis. We're also tied into some of VDOT's systems, such as VA traffic, and exchange data with their systems. The VCC Cloud also exchanges data with two applications that VTTI has created called VCC Mobile and VCC Monitor. Those are shown in the brown boxes on the left here. VCC Monitor is a web-based situational tool that we use for monitoring activities and events within the VCC environment. And we use that tool to monitor all of the equipment in the field in real time. VCC Mobile is an Android-based mobile application that provides an engineering-level user interface platform that can be used to test application exchanges with actual drivers. And we also have a few work zone applications that we're currently working on that send relevant work zone information to passing motorists. So next I'll talk about our SPaT development parameters. Our mission here in deploying SPaT was to deploy in a working VDOT system, which meant that we had to deal with existing VDOT equipment and capabilities. So we didn't go out and procure brand new equipment that had all the nice capabilities already built in. We had to work with what VDOT already had deployed. So therefore we were constrained to using the McCain 2070 controller, which is running the Advanced Traffic Solutions, or ATS D4 firmware. That firmware, when we first started the project, did not have the capability of directly producing SPaT data or the underlying data that could be used to produce SPaT, so we had to develop a custom interface for that. So we contracted ATS to essentially build this interface that will push data through one-way communications protocol that pushes the data through a firewall to satisfy safety concerns. So just to clarify, we're only going one way with the information right now. So data is coming out of the controller, so we can then use it on the RSU and the cloud after that. We're currently running version 4 of the RSU software. From a SPaT perspective, the RSU is set up to listen to the firewall port for any incoming data. And when we do get the data, we receive it and then convert it into the J2735 version 2016 SPaT message standard. So basically, VDOT's sending us, or they're sending us the raw timing and phase data, and then we decide how to build it, encode it, and broadcast it once we receive it. We're not just broadcasting from the local intersections, we're also pushing the data back into the VCC cloud, where we archive it and then also make it available for our cellular application users and any additional applications that may be available in the future that we may want to pick up on aggregate SPaT data. From a security perspective, we aren't running any SCMS right now. We don't have any available providers. I've not necessarily had the requirement to go out and do that at this point. All right, so regarding map file development, we initially built our own tools to develop the map files using photogrammetry, which is essentially top-down photos, and then we click out points to define the lanes, and then use our own code that we wrote to process and put the logic in to determine the approaches. And we did that for the first 6 intersections, and quickly realized that that was going to be a very time-consuming process and difficult to maintain. So at that point, we found out that there was the US DOT map tool that had been developed, that we could use that to follow the same kind of process that we had been using, but it was much faster and then would follow along with the US DOT implementation standard. So once we have the map file developed in terms of where the lanes and approaches are, we take an output of the tool that VDOT uses called MIST, and that's VDOT's central signal management system that they use to update and control all their timing plans on the 1,400 intersections that they have in the northern region operation. And we're able to get that timing plan information out of the MIST system and manually assign phases and complete the map files that way. Currently, our map files are relatively static. We build one up and push it to the RSU remotely using VCC Cloud, and we aren't necessarily able to automatically reconfigure or support changes to the intersection or even daily changes to the flow of traffic, for instance, but we do intend to develop tools to do that sometime in the future. This next slide just kind of shows the flow of data throughout our system, and there's really 2 ways that we can get data to an end user. It all starts with the McCain 2070 controller, where you can enter a port and IP address to enable the flow of the raw signal and timing data through the firewall. The RSU is then set up to listen to that port number at the firewall and take in that data. We then process, encode, and broadcast it. So that's really the most direct route to get data from the intersection. We broadcast it out to a motorist that has an OBU passing by. Additionally, we're able to forward that same message into the cloud, where we can use it in our VCC monitor tool, where we can zoom in on intersections to see a live display of the SPaT data to validate and verify that it's coming through appropriately. We can also make it available to people that have our VCC mobile application, so they can pick it up and get the SPaT display on their phone interface as well. So next, as far as vehicles that we have out there able to receive this information, we currently have a variety of vehicles deployed on the VCC that are capable of receiving SPaT and map data. We have a fleet of 50 personally owned production vehicles that have level 2 automation capabilities that we've instrumented with technology to be able to monitor their performance. And we tested out their use of the VCC mobile application over a period of 12 months of data collection. And beyond that, we've invited various groups of users to also use and try out the VCC mobile application, and the number of people using that varies from time to time. And currently, we're also seeking out third-party application developers who may be interested in developing and testing applications on the VCC as well. So as far as SPaT and map validation, there are a few things we're doing on that front. First, we're evaluating the accuracy and latency of SPaT and map messages. And to do that, we've added a custom wrapper code so that when messages are received and then rebroadcast or transferred throughout the system, we essentially get a list of routing and the timing of where that occurs, so we can see each message and each hub, the routes it took and the time it took to get from point A to point B. We did a fair amount of data collection on the roads and logged the data on our VCC mobile app, and that's currently being used to develop a profile for latency and the characteristics of how the data flows through the system. And those paths that we're really interested in are coming from the controller and into the RSU, and then also into an OBE if it's an integrated system on a vehicle, or the controller to the RSU to VCC Cloud and then to the VCC mobile smartphone app. And we're just trying to understand how those two paths may vary in terms of latency and what impact that could potentially have on applications that we intend to deliver in the future. We've also looked at the SPaT challenge verification document from CAMP to understand their expectations regarding how the messages should be implemented. We went through and evaluated those requirements and have updated several parts of our system, most having to do with how this data can be interpreted. There are still a few missing pieces that we're working on. One is an RTK system that we're using to provide a source for RTCM corrections that will be broadcast out from the RSU. And one of the more time-consuming pieces is also to modify our map messages to support longer approach lengths as prescribed in the document. Currently ours are relatively brief, and we understand the need for the longer approaches. It just takes a little bit longer to put that together. We've also recently added pedestrian phases to support third-party application development, which is addressed in the CAMP document as well. And we've also developed some post-installation and field maintenance validation tools. So we've actually developed a piece of equipment that VDOT's roadside maintenance contractors can use to verify that the SPaT and map messages are being transmitted properly after they perform maintenance on a signal controller. So that's a nice way for them to be able to validate that the system's still working as expected after they complete maintenance. As far as future plans, we're really looking forward to developing our own SPaT and map-enabled applications. We have interest in various applications, some of which are listed here, such as red light violation warning and eco approach and departure. All of these applications are things that we're planning on working on with VDOT in the future, and we also have some traction with OEMs who are interested in coming in and testing their applications in the VCC environment as well. We're also likely to expand the VCC environment and add more RSUs if and when the use cases deem that necessary. Like I said, we currently have 30 out there on 3 or 4 major corridors already implemented, so that's a pretty good test bed for us currently to be able to learn what we need to learn before this becomes more mainstream. And as far as lessons learned, I'll just touch on these briefly since this may come up in the Q&A session as well. I think as Joanna touched upon too, it's important to have regular coordination with the different agencies involved in the deployment. So that's really been helpful. We found that working with actuated signals has a pretty big impact and is more difficult than just using fixed timing signals. So that's something we've dealt with. And again, the map files tend to take a significant time and effort to develop and validate those. And that is the end of my presentation here.